This is worksheet 2 of the periodic table packet, and for many of you this is probably the first video assignment that you've had, so just to let you know, you should have your packet open to this same worksheet. You're going to be highlighting what I highlight as I discuss it. Anything that I write down, you should write down. So by the time you finish this video, your worksheet should look just like mine. And that's your homework, so you can expect that I will be checking it and assuming that you have watched and at least become familiar with the ideas discussed in this video. You may have some questions, and you might want to write those down so that you can ask me in class. And then in class we'll have an assignment that asks you to practice and work with some of this information. The benefit of the video is that you can fast forward if some of this is review, because especially these first couple worksheets, you may have learned quite a bit of this in middle school. But on the other hand, you can rewind and rewatch as many times as you need. So if this information is not familiar to you, you might want to rewatch the video. If you find that you've stopped paying attention and zoned out, you can rewind and rewatch also. So make sure that you have something to write with, make sure that you have a highlighter, and we will get started. This worksheet is meant to review for you, or in some cases introduce the idea of atoms. Alright, so an atom is the smallest unit of one element, the stuff that makes up our world, that can exist on its own. So atoms have in their center a nucleus where most of the mass or the weight of the atom is. And this nucleus is made up of, get my pen out here, protons, which have a positive charge, and neutrons, which have no charge. So that's sort of describing their electrical properties, right? Both protons and neutrons have a mass. They weigh something, so that's why the nucleus itself weighs something. They both weigh 1 AMU. I'll write that in and I'll tell you. An AMU is an atomic mass unit. Okay, trying to talk about the mass of a proton or a neutron in pounds or grams, more common units for weight, would be ridiculous because they're so incredibly small. It'd be like 0.000000001 grams. So we use these units of atomic mass units when we're talking about things that are really, really small. Right? The last thing that makes up an atom is an electron, which has a negative charge. And it does have a mass, but it's so incredibly small that for our purposes, we'll just say it has no mass. So 0 AMUs would be the weight of an electron. And electrons can be found moving around in what we can call an electron shell, or maybe more accurately, an electron cloud. All right. This picture that you see is a model for sort of thinking about the atom that was created by a guy named Niels Bohr, who you'll learn more about later. And it's not totally accurate. Electrons don't move around the nucleus in these perfect little circles or ovals. Okay. But it serves our purposes for the most part to think of them this way. Okay. In truth, the electrons buzz around the nucleus in a sort of specific area. This is why we might call it an electron cloud. Almost the way bees would buzz around a hive, right? Sort of unpredictable, but we can define sort of the space in which we could find them at any given time. So when we look at this sort of idealized picture of the atom, we need to remember it's kind of the equivalent of drawing a stick figure of a person, right? When you see a stick figure, you know it represents a person, but you also know that a real person doesn't look exactly like that. This is a really simplified picture that for most times is going to be enough information for us to do what we need to do with it. Okay? So the other thing to note here is that we organize these elements into the periodic table that we've already talked about in class, and the number of shells, right, the numbers of these rings here, is going to be equal to the row, right, so rows are the horizontal back and forth pieces of the periodic table. So in our example here, we see that there's only one shell, right? And so this element, which is actually helium that we're looking at a picture of here, would be found in the first row of the periodic table. Other larger atoms might have 2 shells and be found in the second row, 3 shells be found in the third row, so on and so forth. Okay? Now, it turns out that the number of protons that an atom has is really important because that's sort of what defines its identity. So I told you guys that in this picture up here, this is actually a picture of helium, okay? And I know that because helium is always an atom with 2 protons, okay? So if these little blue circles here represent protons, we can see there's 2, so I know this is helium, right? If I saw 20 protons, I would know this is calcium, or 79 protons, I would know this is gold. So the number of protons in an atom is a really important identifying piece of the atom, and we call it the atom's or the element's atomic number. And that's one of the 2 numbers that we find listed for each element on the periodic table. Okay, on the periodic table, you'll have 2 numbers. The smaller number, right, is always the atomic number, and that's telling you the number of protons. And then the bigger of the 2 numbers listed on the periodic table is the mass, or the mass number. Okay, and the mass is just adding up all the parts of the atom or the element that have a mass, right? Now, we said that a proton weighs 1, and a neutron weighs 1, and an electron doesn't weigh anything. So if we want to add up the mass, we have to add the number of protons plus the number of neutrons, because each proton weighs 1 AMU and each neutron weighs 1 AMU. So we add them together, we get the mass of the element. Now, it's worth noting that in this particular example, the mass is listed up above in the square, and the atomic number is listed down below. That's not always the case. In fact, on the periodic table that you have in your packet, it's reversed. So you want to remember that the mass is always the bigger number, being that it's the combination of protons and neutrons, and the atomic number is always the smaller number, since it's just the number of protons. We're missing the neutrons in there. Okay? Only exception to this rule would actually be hydrogen. Hydrogen, we already mentioned in class, does not have any neutrons, and so its mass and its atomic number are actually both 1. So hydrogen's sort of a funny little element. It's the one exception to the rule. Okay, so just to kind of review what we already said here, a proton has a positive charge. So I'm going to fill this in, and so should you. Okay, its charge is +1. And it has a mass of 1 AMU. Okay, I'm just going to write, AMU here, so we know all of our masses are in AMU. Okay, and you can remember from the model up above that it is found in the nucleus of the atom. Okay, and you can also remember from up here that the way we know how many protons are in a particular atom, if we look at that atom on the periodic table, is by its atomic number, right? The atomic number is equal to the number of protons. Okay, an electron has a charge of -1. We already saw that up above. Remember, it's the one that weighs effectively 0. And it is found in the electron cloud. Okay, and for our purposes, for the extent of this packet, the number of protons and the number of electrons should be equal. Okay, because we want to make sure that all atoms are neutral, meaning they have a charge of 0. That's what neutral means. Well, if you want to have a charge of 0, that means you have to have the same number of positives as negatives. In other words, you need to have the same number of protons that are positively charged as electrons that are negatively charged. Because that way, when you add up your positive charges, your protons, and your negative charges, your electrons, they're going to add up to 0, right? For example, in helium, that was the atom we had a picture of up above, you had 2 protons, positively charged, and you had 2 electrons, so 2 negative charges. Well, positive 2 plus negative 2 equals 0. Okay, so what that means is, for our purposes for the time being, if you know the atomic number of an element, the smaller number in its square on the periodic table, that's not just its its number of protons, it's also its number of electrons. Now, there's an exception to this rule that we'll learn about near the end of this packet. When we start talking about things called ions, that's where the numbers of electrons start changing, because atoms can actually give away and steal electrons from other atoms. But for our purposes now, protons and electrons should be equal in number in a neutral atom. All right, the neutron, get it, has a charge of 0. It has a mass of 1 AMU. We talked about that up above. And like the proton, it is found in the nucleus. Okay? Now, if we want to know how many are in an atom, if we're looking at the periodic table, right, and let's say, for example, we're up here looking at oxygen, okay? We know the mass number of oxygen is 16. We know the atomic number is 8, because those are in the square. If we want to know the number of neutrons, we can actually do a little subtraction problem. Okay, keep in mind that the mass is the number of protons and neutrons. Okay, and the atomic number is just the number of protons. So if we want to end up just knowing the number of neutrons, all we have to do is the mass number minus the atomic number. I want you to think a little bit about that. Mass minus atomic number. All right? By subtracting the atomic number, we're taking out the protons, and then we're left with just the neutrons. So another way to think of this is the big number minus the small number. Okay, so for the example of oxygen, it would be 16 minus 8. Okay? All right, so I want you to put a big star next to this table, because you are going to see this table a lot. You will see it on the unit test at the end of this packet. You will see it on your midterm exam. You're going to keep coming back to this. When we start our next packet, you're going to have to write this table out again so that you have it to refer to. All right, so this is one of those things that you need to commit to memory, and the sooner you do, the easier your life is going to be. So when you get to class next, we will start practicing using some of the information in this table.